All right. Hey, everyone. Thank you so much for coming out. This is Serving Content on the Web from PHP to RSC and beyond. My name is Adam Rackis. Thank you, Ken. By the way, there is a disturbing number of empty White Claw cans back there. I don't know what is going on backstage, but someone should look into that. This is going to be a talk about how frameworks have evolved over the last decade or two. But we're not going to focus on low-level syntax, because that's boring. I want to talk about how frameworks have evolved to make better use of networks and web servers. We're going to think about things like network latency, round trips across the network, and why that matters. I want you to stop thinking about your network as some simple thing against which you call fetch to get data back quickly. That may be true when you're vibe coding a to-do list on localhost against an SQLite database. But in reality, it's going to look a little bit more like this. I want you to think about round trips across the network as the single most expensive thing that your web application can do, because most of the time, it will be. Let's take an extremely brief walk back in time, talk about the history of the web, and we're going to go back to the 1990s. That's right, best decade. In the beginning, if the user wanted to hit a website, they'd punch it into their browser, and the server would send back a fully formed HTML page. We used to manually generate HTML on the server with no JavaScript in sight. Back then, we would use long since forgotten, deprecated, obsolete programming languages like Perl and PHP. I kid. Laravel team's going to cancel me. And these websites could even be interactive, kinda. Not with fetch. That wasn't added to the web until 2015. If that 90s meme really hits you hard, you might be thinking XHR, and it gives me no pleasure to say this, but that was added in 2000. That's just brutal. This is how you generate XHR code in 2025, by the way. JavaScript itself wasn't added to the web until 95. Back then, if you wanted interactivity on the web, you had to use a form. Forms were the original fetch. If you tilt your head and kind of squint a little, they send your whole page over the wire to wherever you tell it to send it, and you get back a brand new page, or maybe the same page on it. And even the page reload is negotiable. Once JavaScript came on the scene, tools like ASP.NET MVC allowed us to use a form to update a single part of our page with no page refresh. And of course, Remix came along a decade or so later and made it popular again. But it's hard to build a rich interactive experience with just HTML forms. So what do I mean by that? Let's look at something real. This is the part of the talk where I get to show you what I work on. My finger slipped. So I work on Spotify for Artists, and I've gotten approval to show you what that looks like. That's the web portal that our artists log into. And I have an artist that I can show you, and he's given me permission to show you his S4A pages. Mr. MC himself, Ken Wheeler. This is what S4A looks like. Here's just a very small sample. Here's a page that shows some of his music. It's got his stats. There's some filters we can interact with. Here's a data visualization of his listeners. Huge sausage party. 94% dudes are listening to Ken Wheeler. We've got data visualizations for his stats. Obviously, it's interactive. You start messing with those checkboxes, and the data visualization will update in real time. This is what his profile page looks like. Let's sit here for just a minute, and let's just look at all the pieces of data that we need to put that together. In the very top right-hand corner, that's the currently logged-in user. That's me. We'll go clockwise from there. Monthly listeners, we hit a service to get that. Artist pick. If you've ever been on the Spotify music player on an artist's page, you might have noticed the artist pick. That's something the artist can select to sort of feature for you. It could be a single, recently released album, whatever. We've got his discography, popular tracks, and I left some more out. If you are a user who can access multiple artists, like me, I can access any artist as an employee. That's the recently viewed artist. We hit a service to get that. And even those navigation endpoints, pretty much every single one of those needs to hit a separate service to check a separate permission to see if we can show that nav endpoint for the current user for that artist. Lots and lots of data. Could we build that in PHP? Absolutely. Even without cool, modern PHP tools like Laravel, you could totally build that in old school PHP. Generating the content itself would be easy. Even the data visualizations would be fine. Those are just SVG tags. Don't let the colors or the lines fool you. They're just SVG tags. But it gets a little more interesting with all the interactions. Things like, just simple things like clicking that button and getting a popover. We need some JavaScript to show that. As you click on the checkboxes, we need JavaScript to hear those clicks to send a request to get the new data visualization and update the DOM. The artist pick. If Ken were to click there, we would show a widget, and Ken could search his discography, pick a single, pick an album, and select his artist pick. It's not shown, but I actually built that widget, and I built it with React Aria. So if Devin Govett is listening, thank you for that, sir. So the content is easy, but it's the interactivity. But we have tools to manage that, right? Great tools, wonderful tools. We can take server-generated content, and we can just slam jQuery on it. And we can go to town, right? jQuery is a beautiful, fluent API. It lets us select any part of our DOM, attach click handlers, update, remove, clone, replace anything on our page. We can do whatever we want, and it's fun. But if we're honest with ourselves, as our app grows larger and larger and larger, it gets more and more difficult to keep all of that jQuery content organized. To say nothing of the fact that it runs on CSS selectors, which are global and can collide with one another. Spotify for Artists is managed by over a dozen different teams of software engineers. If we were to build that with just jQuery, it would get disorganized really quickly. So we have an impedance mismatch, right? It's not the 90s anymore. We're not rendering a chunk of static content for users to look at. I mean, we might be. There's plenty of that on the web, and if that's you, keep on using whatever you want. But if you're building an interactive software application, some of these older tools may not fit as well. And so we started asking ourselves, why don't we just build the whole app on the client? Why don't we just bypass the server, and we'll just use client-side JavaScript to build everything, rather than try to ram on all these interactions onto server-generated HTML. And we did. And we started building tools to help us do that. And then we started building better tools to help us do that even more effectively. We said, we'll just sidestep the impedance mismatch, and we'll have the server just send down an empty shell of a page, always. And then client-side JavaScript will take over and build the application. That's why it's called a single-page application, because the server is always sending down the same single empty shell of a page. So what's the problem? Not much. SPAs were great. They still are great. And don't let anyone tell you otherwise. And I'll go even further. Sending down a few hundred kilobytes of JavaScript is fine. That's not going to be why your business failed. SPAs won't work without JavaScript enabled. So what? That's fine. Who cares? SEO actually may suffer a little, so if that's important to you, maybe proceed with caution. But there is one sort of grown-up trade-off that I want to talk about. When we stop server rendering our page, we go from this to that. And now the server is sending down just an empty shell of a page, and the user's just looking at a loading spinner. And now our browser has to do multiple round trips across the network before we can show them something useful. First, we have to load all those script tags. They might be cached on a CDN, or they might not. Once the script tags are loaded and parsed and executed, our React components are going to come to life. And then they're going to probably request some data. So that's going to be more round trips across the network. And then eventually you get all your data, and you can show your page. And life is good. And this is fine. And again, this is good enough. But we wouldn't be good engineers if we didn't say, maybe we can do better. We were building these software applications in the browser with client-side JavaScript. We gave up server-side rendering, and now our web app needs some more round trips across the network before we can show content. How can we fix this? So you might be saying, well, this is a non-issue because React has APIs to server render. It's not really called React.stringify, but there are APIs that run on the server from React that will take a component tree and stringify it into HTML. And we can do that and send that over the wire. We'll have JavaScript running on our web server, on Node or Bun or whatever. And then on the client, we can re-render the same component tree with client-side React APIs. And I know it's not React DOM.render anymore, but that doesn't matter. And we'll render the same component tree in the same place, and it should produce identical content. And that's called hydration. The problem is data. We forgot about our data, right? On the server, we're actually going to need to load some data, which is easy. And we'll need to pass that to our component tree somehow. That's easy. But then we have to do something really weird and kind of dirty. We have to take all that data, and we need to ram it into our HTML page somehow. We need to create some script tags somewhere, somehow, and create some global variables and just dump all that data into some global variables so that when we render on the client, our components can just grab those data from those global variables because we don't want to re-request it. It's in a different place now. And it's kind of a pain to get right. And it would just be so cool if a tool could just do that for us. And this is where the meta frameworks started getting born. Most people think about Next in terms of file system-based routing. But for me, solving this problem is the main value proposition of frameworks like Next. It gave us a place to load data on the server, and then Next does all that filthy work to make those data available in our components without us having to think about it. Huge step forward, but now we need to load all the data for our path in that one function. We've seen how much data even a relatively simple page like this can require. It would not be fun trying to fit all of that into that one function, right? And there was no way to invalidate back then. You couldn't, with that old Next, say, hey, my data have changed, rerun, get server-side props. And also, as you browse around your web application, let's say you browse from page 1 to page 2, and then you browse back to page 1. Do we want the server to rerun and fetch fresh data, or do we want to just re-show what was already fetched? You might want either. There's no correct answer to that question. But your framework might have an opinion, too. We have a new kind of impedance mismatch. We don't have a fully client-run application anymore. We have a client-run application with a bunch of stuff constantly happening in the server that we have to interact with. And this brings us to the second, what I like to call the second generation of meta frameworks. And I'm sorry, but I refuse to call it React Router. It's Remix. What a beautiful logo. Cool. That's right. It's Remix forever. And SvelteKit's cool, too. These frameworks gave us a lot of things, but they gave us layouts. So we can take chunks of our URL, and we can attach layouts to them. And the layouts can have loaders in addition to markup. Each loader can load whatever data it wants for its own chunk of the URL. And these loaders can be invalidated. You can now say, hey, I've changed some data. This loader needs to revalidate and rerun, or these layouts, or loaders. And I don't think enough people know about this, but you can actually create artificial synthetic layouts that have nothing to do with your URL. You can just inject them into your component tree, and you can load data in them without messing with your URL. There's like special syntax, like wrap it in parentheses or whatever. You can check any framework's docs on that. Conceptually, it's this. This is hardly production-ready code, but this loader, if we're building a Jira clone, it might load some tasks, some epics, some milestones. But the loaders invalidate all or none. It's one function on the server. It runs or it doesn't. And again, what if you browse back to a page you just looked at? Do we want the server code to re-execute? Or do we want to just re-show the content that we just loaded a few seconds ago in the same session? Either is valid, but your framework's going to have an opinion. And like I said, the revalidation is all or none. Let's say you edit a task, and then you tell Remix, hey, revalidate this loader. The tasks will reload, but now the epics and the milestones are going to reload too. You don't need those reloading, but they are anyway. So again, this is fine. If that breaks your back end was already broke, and you weren't going to make it. But networks can be unreliable sometimes, and the more pieces of data you're superfluously reloading, the better the chances some of them might randomly be slow for conditions outside your control. And maybe some of your queries are just slow. Everything can't always be fast. There's limited resources. And you could keep breaking these loaders up into those smaller and smaller synthetic loaders, but that's going to get to be tedious. What are some other approaches we could use here? Next, I don't know how to describe it, Next 14 or Next 2.0, Next app directory, React server components. Incredible step forward. You can load data right in your React components, and they only ever run on the server. And if you have sibling components that load data, they will run in parallel. Be careful not to load data in parent and child components. That can create a waterfall. You have to hoist the loading and pass the promise. But the revalidation is actually worse than Remix, because when you call revalidate tag in Next app directory, the entire RSC component tree is going to re-render from top to bottom. And all your fetches are going to reload. Revalidate tag only clears the cache for that tag. Vercel is banking on you having cached most of those calls so that when you revalidate tag and refetch everything, they're all cached. And this isn't like a bad design decision. There's no other way to do this. There's no way for your server to be like, all right, I'm going to just inspect this hypothetical component tree and only request these pieces of data, and then somehow JSX is just too dynamic for that ever to work. And let me be clear, this is great. Like, RSC and app directory are phenomenal for plenty of use cases. E-commerce especially, if you don't have a ton of granular pieces of data loading, this is great. This model fits fine with plenty of use cases. But let's back up. Is there a way to truly kill this impedance mismatch? We already had great client-side data loading. Remember React Query? Pepperidge Farms remembers. We can write code like this. We can give it a hierarchical query key. We can tell it how to load data, give it some cache settings. And then later on, we can say, hey, invalidate query and say epoch number 12. Or we can just give it the first part of that hierarchical query key and just say clear all of the epochs out with one fell swoop. And you might say, well, can't I just do that in Remix? I can just pull in React Query into Remix. Sure. But remember, your loader in Remix is fetching your initial data on the server, so you're going to need to integrate that in React Query. And you can. There's a property for that, initial data. And so when you stick initial data into your use query, React Query will always just use that, and it will never touch the network. So make sure that when that epoch ID variable starts changing, you realize it and you pull the initial data out. And then later, your loader might revalidate and send you fresh data. So stick that fresh data back into the use query hook. And then when the user starts interacting with your app again, pull it back out. It's the impedance mismatch again, right? We had it so good in the SPA days. We decided to add some server rendering back in just because we wanted that perf to be a little bit better for that initial page load. It would be so cool if we could just have our server render that initial page and then just back off and give us back our SPA. And this is where we come to this latest generation of meta frameworks, Solid Start and TanStack Start. Not enough people know about Solid Start. It came first. Ryan has always been a little too late, but he's brilliant. And TanStack Start. These tools give us isomorphic loaders. That's the benefit of JavaScript. It can run on the server or inside your browser. And so think Remix, but the loaders run on the server only for your initial page load, and then they run on the client. And it's tightly integrated with React Query or Solid Query. And SvelteKit does have isomorphic loaders, but there's no data fetching integration. Let's see what TanStack Start looks like. At the top, we've got our loader, and at the bottom, we've got our component. Query client can exist in either, and query client is the same query client you already know from React Query. And so we can say query client.ensure query data. When that runs on the server for our initial data load, that will fetch our data on the server, and it will do the work of putting it inside our page. And then in our component, for our first page load, it will read that server fetch data. And you don't have to mess with initial data. TanStack Start will do that for you. It's all well integrated. The user starts browsing around. If they come back to this page, the loader will always run again. That's not true. There's cache settings for the loader. But with this code here, the loader will always rerun, but it'll run on the client. And so that means when query client.ensure query data runs, every other time subsequently, it'll run on the client. So it can look at your client-side query cache that you already have. So you could have invalidated any tiny piece of data, and this code will only load exactly what you need, no more and no less. After the initial render, everything runs on the client. So you get back all the benefits of your SPA, but you get those performance benefits of still server rendering your initial page. And TanStack Start even supports single flight mutations. What that means is if you send a network request to modify some data, you can perform that modification, and then after the modification, you can have server-side middleware fetch you some queries that you know are active on the page that will reflect the changes you just made and push those data down. And then you can have client-side middleware catch that updated query data and push it down into your React Query cache. So your UI will update with just one round trip to the server. And if there's some Vercel people here, they're very mad at me right now. Next will do that too. Next app directory will absolutely support the same thing. Revalidate tag, revalidate path will also do that, with the caveat that the revalidation will refetch everything. Expect a blog post from me on that in the near future. All right, big hat tip to Dan Abramoff. If it wasn't for him, I would have just gotten up here and been like, hey, TanStack Start's just better. It's just a better model, period. But he did correctly point out that if you do something stupid with TanStack Start, you will pay a bigger price. If you sequentially load data in your loader like this, that will create a waterfall. The first thing will block and load, and then the second thing will block and load. And that will run on the client for every single time this runs, except for the initial load, and that's going to be expensive. Those are round trips across the network. So just don't do that. Do this instead. Load them in parallel. Now, if you're saying, well, my backend is busted, I actually truly do need to load things sequentially, that's fine. Just take that sequential data loading and stick it in an API endpoint. Create a BFF, a backend for front-end service, put in an API endpoint. Those always run on the server, and then you can just fetch that from your loader, and that sequential data loading will always run on the server, which is as good as you can do until you fix your backend. Real quick, I only have 22 minutes, so I'm wrapping up here. If your data loading is slow, if you actually have data that's slow to load, when you try to server render that page, the user's not going to get a loading spinner. They're just going to get a blank screen on their browser. You can actually do something called streaming. And don't think like video streaming, although kind of the same idea. Any of these frameworks will support it, except for original next pages directory. But the idea is you can start your data loading on your server and then render your page, and the server will push the data down whenever it happens to be ready. So on the one hand, it's kind of the best of all worlds. I would caution you, use it judiciously. If you stream everything on your page, your UI could get a little janky, and you'll see pieces of data just popping in everywhere. Not the best UX, in my opinion. Try to server render most of it, and then maybe if you have some side data, you can stream those in lazily. Read the docs for your framework of choice. They all support it. Use it as needed. In closing, this talk was not about, hey, this framework is better than that framework, better than that other framework. The idea was to get you thinking about these things, to get you thinking about network round trips and how your framework is interacting with your network and how that's going to affect your performance for your end users. Moreover, it would just take a few small changes in Remix to do everything that I showed TanStack Start doing. Make the loaders isomorphic, and integrate tightly with React Query. If you're into Vue, I have heard amazing things about Nuxt. They solve many of these same problems slightly differently. I would urge you to check that out if you're interested. And that's my talk. Thank you so much for listening.